If Earth had a twin orbiting a red sun just 40 light-years away, would it be our next home or our next graveyard? Because Gliese 12b might look like Earth, but it doesn't behave like it. In 2024, astronomers discovered a planet almost the same size as Earth, sitting in what could be its star's habitable zone. It's called Gliese 12b, and it instantly became one of the most exciting exoplanets ever found. Today, we're going to travel there step by step. From the impossible journey across interstellar space to standing on its surface under a red dwarf sun. And by the end, you'll know whether this world could actually support life, or if it's far more dangerous than we imagined. Gliese 12b is about 40 light-years away in the constellation Pisces. That might not sound far on a cosmic scale, but with today's fastest spacecraft, it would take hundreds of thousands of years to get there. Even if we could travel at the speed of light, which we can't, it would still take 40 years just to arrive. So for this thought experiment, let's assume humanity has cracked advanced propulsion. Fusion drives, light sails, something powerful enough to shrink the trip down to decades instead of millennia. You leave Earth. The sun shrinks behind you. The planets disappear. The solar system becomes a pale dot in the darkness. For years, there is nothing but stars. Then one of them slowly grows brighter. Not yellow, red. Red dwarfs are the most common stars in the universe. They're smaller, cooler, and dimmer than our sun. But don't let that fool you. They can be incredibly volatile, releasing massive stellar flares that blast nearby planets with radiation. However, Gliese 12 appears to be less active than many red dwarfs we've studied. That's one reason scientists are so excited about its planet. Because if a world is going to survive around a red dwarf, it needs a relatively calm one. And Gliese 12b sits very close to this star, completing one full orbit in just 12.8 Earth days. That means its entire year is less than 2 weeks long. But here's where things get strange. Because Gliese 12b orbits so close to its star, it's very likely tidally locked. Just like the moon always shows the same face to Earth, this planet may always show the same face to its star. Which means one side is in permanent daylight. One side is in eternal night. Imagine standing on the day side. The red sun never moves. It hangs in the same spot in the sky, forever. No sunrise, no sunset. On the night side, total darkness, possibly freezing temperatures, a sky filled with stars that never shift position. But between these extremes lies something fascinating. A narrow band around the planet called the Terminator Zone, a region of perpetual twilight. And this strip might be the most livable place on the entire world. Here's what makes Gliese 12b truly exciting. Its radius is about 0.96 times that of Earth. That means it's almost the same size as our planet. And in exoplanet science, size matters. Because planets around this size are likely rocky, not gas giants. If its mass is similar to Earth's, which we're still trying to confirm, then its gravity could feel very familiar. You might be able to walk normally, jump normally, move normally. But size alone doesn't make a world habitable. The real question is temperature. Based on its distance from Gliese 12, scientists estimate that if the planet had no atmosphere, its equilibrium temperature might be around 42 degrees Celsius, 107 degrees Fahrenheit. Hot, but not Venus hot. However, that number changes dramatically depending on one critical factor. Does it have an atmosphere? If it has a thick, greenhouse-heavy atmosphere like Venus, surface temperatures could skyrocket. If it has a thin or no atmosphere, radiation from the star could sterilize the surface. But if it has a stable, Earth-like atmosphere, liquid water becomes possible. And where there's liquid water, life becomes possible. You descend through the atmosphere, if one exists. The sky above you is not blue. Red dwarfs emit more infrared light than visible light. The sky might appear dim, hazy, perhaps tinted in strange oranges or deep crimson hues. The sunlight feels weaker than Earth's in brightness, but the infrared radiation warms your suit. If you land in the Terminator zone, the star sits permanently on the horizon, a glowing red half-disk that never rises or falls. Behind you, the sky fades into eternal night. Ahead of you, it brightens into endless day. Winds might rage across the planet as hot air from the day side rushes toward the freezing night side. If oceans exist, they may form a ring around the twilight band. You could be standing on the shoreline of humanity's second home, or on a sterile rock. We don't know yet. But here's the problem. Red dwarfs are notorious for something deadly: stellar flares. Even relatively calm red dwarfs can unleash bursts of radiation powerful enough to strip away a planet's atmosphere over time. And if Gliese 12b lost its atmosphere early in its history, it could now be nothing more than a dry, irradiated wasteland. There's also tidal locking. Without atmospheric circulation, the day side could become scorching, while the night side freezes solid, causing atmospheric collapse. And we don't yet know its magnetic field strength. Without a magnetic shield like Earth's, solar particles could bombard the surface directly. So the biggest mystery isn't distance, it's survival. To understand whether Gliese 12b could truly support life, scientists are turning to powerful instruments like the James Webb Space Telescope. By analyzing the light that passes through the planet's atmosphere during transit, researchers can search for chemical fingerprints, water vapor, carbon dioxide, methane, oxygen. Each molecule leaves a signature in the starlight. If we detect water vapor, that changes everything. If we detect oxygen alongside methane, that could hint at biological processes. But even without life, Gliese 12be represents something profound. It shows that Earth-sized planets in potentially habitable zones are not rare. They may be common. And if they're common, then the odds of life elsewhere rise dramatically. Let's imagine the best-case scenario. The planet has a stable atmosphere, moderate temperatures, surface water, manageable radiation levels. Could we terraform or colonize it? Possibly. The biggest challenge wouldn't be gravity or temperature. It would be distance. Even with advanced propulsion, maintaining a supply chain across 40 light-years is nearly impossible. Colonists would need to be fully self-sufficient. Generations might live and die before ever seeing Earth again. Gliese 12b wouldn't just be another colony. It would be the beginning of a separate branch of humanity. Now imagine this. Decades from now, James Webb, or its successor, detects clear signs of water vapor and a balanced atmosphere. Then something even more shocking appears in the data. Oxygen and methane together, in chemical disequilibrium. On Earth, that combination is largely maintained by life. Suddenly, Gliese 12b isn't just a candidate for habitability. It's alive. 40 light-years away, under a red sun that never sets, life has found a way. And for the first time in human history, we are not alone. The night sky would never look the same again, because one of those faint red dots wouldn't just be a star system. It would be a living world. Gliese 12b is nearly Earth-sized. It orbits a relatively calm red dwarf. It sits in a region where liquid water could exist. But we still don't know if it has an atmosphere. We don't know if it has oceans. We don't know if it's barren or thriving. What we do know is this: The universe is filled with planets, and some of them look eerily like home. Gliese 12b might be humanity's future destination, or it might simply remind us how rare and precious Earth truly is. Either way, it proves something incredible. We are living at the moment when distant worlds stop being science fiction and start becoming places. And if you enjoyed the video, make sure to like and subscribe and check out the channel to find more amazing and new videos